Hello, how are we doing today? We are going to talk about the slope formula. So we already know what slope is. It's that rise over run. In other words, it's the slope of our line. It's basically how gradual or how steep our line is. So if it's a steep line, then it'll be almost straight up. If it's a gradual line, it is more horizontal. It's taking its time. And that's what we're talking about with slope. Slope is just talking about the rate of change. So, we are going to learn how to find the slope using this formula. So we have our slope, which is m. Anytime you see the variable m, we're talking about our slope. Our slope is our rise over our run, which really means our rise is up or down, if you think about rising. And so that means our change in y. And our run is our change in x. So it's the change in y over the change in x. And then we have this other formula that says y2 minus y1 divided by x2 minus x1. And what that means is that if you were given 2 points, so some point x1, y1, and some point x2, y2, you would be able to find the slope using this m equals y2 minus y1 divided by x2 minus x1 just by plugging in the numbers into their correct spots. My y1, my y2, my x1, and my x2. So we're going to practice using these. So example 1, we want to calculate the slope of a line between the two given points. Well, we're given the points for letter A, -8, 4, and -10, 5. So we are going to end up using this m equals y2 minus y1 divided by x2 minus x1. And so we're going to start off, and we're just going to label our points. Now, it doesn't really matter if I let this be x1 and y1, and let this be x2 and y2. I could flip it around if I wanted to. I could make this x2 and y2, and this x1 and y1 if I wanted. That part doesn't really matter. You just have to make sure that you keep the x2 with the y2 and the y1 with the x1, okay? That's the part that matters, is that the ones go together and the twos go together. Also remember that our ordered pairs are always x and then y, okay? They're always x and then y. So you'll get an x from both parentheses and you'll get a y from both parentheses or points. So let's go ahead, and now that we've kind of covered the basics, let's actually practice this. Well, we have labeled our points x2, y2, and x1, y1. So here's our formula, y2 minus y1 divided by x2 minus x1. And this is equal to, well, our y2 is 4. So instead of y2, I'm going to write 4. Okay, and I'm just going to plug those numbers in for the variable. So I plugged in 4 for y2. Well, then y1, looking at our problem, y1 is over here, and y1 is 5. So instead of minus y1, I'm going to write minus 5. Well, then we need our x2, which in this case is -8. So we're going to plug that in for -8 in for x2, and then our x1 is -10. So we are going to subtract, because notice how it says subtract. But instead of subtracting x1, we're going to subtract 10. And now that we plugged our 4 numbers in, we just have to do this math. Well, 4 minus 5 is just -1. 8 minus the -10. Thinking back, remember that 2 negatives mean this is positive, so we really want to know what -8 plus 10 is. And you could use your calculator for these if you wanted. So -1 is still -1, and -8 plus 10 is +2. So our slope is -1/2. That is our slope. That is what m equals. And we found that just by using this formula. And so what this means, if we were going to graph this, this means that our rise is -1. In other words, we'd go down 1, and our run is over 2. So we'd go over or to the right, over to the right, 2. And that's what our slope means. So let's practice a couple more. We're going to use that formula again. so again, start off by labeling. So I'll let this be my x1, y1, and here's my x2, y2, and I'm just going to plug those in to my formula. Alright, so it'd be a good idea to pause and see if you can write this for yourself, just to make sure you understand what's going on. Alright, so instead of y2, I'm going to write -2. Instead of y1, I'm going to write -7. And then looking at my x2, it's 3. Subtract my x1, which is also 3. And now let's do that math. -2 minus 7 is -9. 3 minus 3 is 0. So in your calculator, if you type -9 divided by 0, what does it say? If you typed it in, hopefully it said error, because we can't actually divide by 0, which means this isn't actually possible since we can't divide by 0. So this is going to be our undefined slope. Undefined slope. And if you think back, remember that means it's just a vertical line. So that's what happens anytime you divide by 0. We have a couple more. It'd be a good idea to pause and try and finish these last couple for yourself. So letter C, we have 0, 5, and then 4, 13. So again, we're going to start off just by labeling our x1, y1, and our x2, y2, and then we can go ahead and we can plug those into our formula. And I like to write my formula down each time, just so I remember where my numbers go. It also, the more familiar you are with the formula, the easier it will be to do this process also. So it just helps you memorize it. So instead of y2, we're going to have 13. Instead of minus y1, we're going to have minus 5. And then we're dividing by x2 in this case is 4, minus x1, which is 0. Well, 13 minus 5 is 8. 4 minus 0 is 4. Well, looking at this, what's 8 divided by 4? We can actually do that because we can divide 8 by 4 and we can divide 4 by 4. Well, 8 divided by 4 is just 2. 4 divided by 4 is just 1. So our slope is 2 over 1, which we could also write as 2 if we wanted. Letter D, again, same thing. We have our x1, y1, our x2, y2. It'd be a good idea to pause and see if you can do this one all by yourself and then check your answer at the end. We can plug our numbers in, so we'll have 6 minus 6, because y2 and y1 are both 6, divided by 4 minus a -1. Well, 6 minus 6 is just 0. 4 minus a -1 really means 4 plus 1. And if we use our calculators, what is 0 divided by 5? Well, either in your calculator or in your head, hopefully you know that 0 divided by 5 is just 0. So for this problem, our slope is 0. And if you recall, that means it would be a horizontal line. So that's how we use that slope formula in order to find our slope. Now, we have a couple more examples to look at. So, changing gears a little bit, the table of values has been completed for each equation, and we want to calculate the slope. We want to find m from the table of values. Okay? So, our equation is y equals x minus 4, and here is a table of points or values that are on that line. So in order to do this, remember that we also said that slope is our rise over our run. Well, we said that rise is our change in y, and we said that run is our change in x. So we're going to use that fact. Here's my change in y, which is my rise. Here's my change in x, which is my run. Okay, so in order to figure out our slope, all we need to figure out is the change. All we need to figure out is how far apart our numbers are. So looking at this, to get from -6 to -5, we would add 1, because -6 plus 1 is -5. Well, -5 to -4, we'd add 1. -4 to -3, we'd add 1. -3 to -2, we'd add 1. So if we're looking, what's happening in our y column? Well, each time, or each new point we go to, we're adding 1. So our change in y, our rise, is just a +1. And that's the first part of our slope. Then we're going to do the same thing for our change in x. Well, to get from -2 to -1, we would add 1. To get from -1 to 0, we would add 1. To get from 0 to +1, we'd add 1. And to get from 1 to 2, we'd add 1. Well, looking at this, it's the same thing. Each time, we're just adding 1. So our change in x is just a +1. And we could leave our slope as 1 over 1, or if we wanted to simplify it, we could write m equals 1. And that's our slope. And all we needed to do to find it was to figure out how far apart the points in our table are. Because remember that the points in the table represent points from our graph. We're going to try a couple more of these, so same type of thing. See if you can pause and figure out how far apart these are. So here's my rise, my change in y, and my run. Well, to get from 8 to 5, we'd have to subtract 3. From 5 to 2, we'd have to subtract 3. 2 minus 3 is -1, and -1 minus 3 is -4. Notice that since these are linear, that's why they have that constant slope. Since they're linear, that's why they have that constant slope, so that's why all of these are -3. Then for our x, we'll do the same thing. Well, -2 to -1, we'd need to add 1. -1 to 0, we'd add 1. 0 to 1, we'd add 1. 1 to 2, we'd add 1. So for our rise over run would be a -3 over +1, which we could also just write as m equals -3. That's our slope. Now, it'd be a good idea to pause and see if you can do this next one for yourself. So here's our rise, here's our run. Well, -4 to -2, we'd add 2. -2 to 0, we'd add 2. 0 to 2, we'd add 2. 2 to 4, we'd add 2. And looking at this, if I didn't know how far apart -6 and -3 were, I could go to one that's easier, right? I know that to get from 0 to 3, I'd have to add 3. I know to get from 3 to 6, I'd have to add 3. So I could start at a different point in my table. If I wasn't sure, again, if I didn't know off the top of my head what -6 plus what would get me -3. Well, here we have a rise of 2 over a run of 3. So that's 2/3, which we can't actually simplify. So for letter C, our slope would just be 2/3. What patterns do you recognize? So what patterns do you recognize that can make this easier? Okay. Hopefully, again, you notice that it's constant, that each time our numbers were the same, right? Our numbers were the same because they're linear, and that's going to help you out. All right. Last but not least, we want to calculate the slope using ratios for these special cases. So these are just special cases of our slope, so let's see what happens. We're going to do the same thing we were doing before. Here's our rise, here's our run. Well, to get from -5 to -5, well, we're just adding 0, and that's what makes this a special case, is the fact that we're adding 0. For our x, well, -2 to -1, we're just adding 1 on this side. So in this case, our rise is 0 over our run of 1. Well, 0 divided by 1 is just 0. So this is a special case where our slope is 0. For letter C, when x equals -2, well, notice how our y values change. So to get from 5 to 6, we'd add 1. 6 to 7, we'd add 1. So that's our change in y, is just adding 1. And our change in x, well, to get from -2 to -2, we're just adding 0. So this is a special case where our change in x is 0. Well, we have our slope is 1 divided by 0, but we can't divide by 0. So for this problem, our slope would be undefined. And that is our notes for the day. Remember to finish your practice problems before you submit this. And if you have any questions, just Schoology message me or arrange a time to talk with me on Teams.